Hello everyone. So in this video, we will be discussing Gauss elimination method. So basically, Gauss elimination method is one of the many ways in solving linear systems. So Gauss elimination method is under the direct methods for solving linear systems, meaning to say we can have certain processes and then we can already get the result or the roots of our linear systems. So for this one, Gauss elimination method, we have here an example. Solve the system using Gauss elimination method. We have the x sub 1 minus 3x sub 3 is equivalent to negative 2. We have 3x sub 1 plus x sub 2 minus 2x sub 3 is equal to 5. And we also have 2x sub 1 plus 2x sub 2 plus x sub 3 is equivalent to 4. So in solving this kind of linear system or linear equations, we need to subscribe this one or transcribe this one into our matrix form. So that being said, we need to get the coefficients of our system and then put that one or write that one in a matrix form. So we have the coefficient of our x sub 1, which is equivalent to, we'll just write this one as equivalent to 1. And since we have no value for the x sub 2, so that is automatically equivalent to 0. And for the x sub 3, we have negative 3. And then we have the equivalent, which is negative 2. Following the same process, we have 3, we have 1, we have negative 2, and we have positive 5. And we have the last row, which is 2, 2, and 1. And then we have the 4. So basically, for the Gauss elimination method, what is our objective here is uh, retaining our diagonal elements to be equivalent to 1. All the diagonal elements must be equivalent to 1, and these elements below should be equivalent to 0. So regardless of what's the equivalent values of the elements of the upper elements that we have here, upper elements from the diagonal, that does not matter so long as you can find or you can get one diagonal elements of 1, and this one should be zeroed out. So in this case, you just need to find your own solution or your own process just so to zero out this one, and this should be equivalent to 1. So there's a lot of process that is just really up to you, how comfortable you are, or what is your preferred solution or processes in solving this kind of problems. So in this case, the first step must you must have these values or elements to be zeroed. This should be equivalent to 0, meaning to say 3 must be replaced by 0, 2 must be replaced by 0 as well. So that being said, we need to get the row 2 first as equivalent to 0. So in this case, we can multiply this one, we can add and multiply that with its negative value. So meaning to say, our row 2, this is our row 2, this is our row 1 and row 3. So row 2 can be added with the negative number of our given value. So negative 3 multiplied by 1, that is equivalent now to our new row 2. So let's try to see this one. Negative 3 multiplied by 1, that is negative 3. And we have the R2, which is 3. So meaning to say, R3 minus 3, that is equivalent to 0. So meaning to say, our new row 2 now is equivalent to 0. So rewriting that one into another matrix, we have copying the first row since we are not altering anything in this row. Then for this one, we can already change that one to 0. And then continuing the same process with the other elements on the same row. So we have negative 3 multiplied by 0, we have 0 plus R2, which is 1, so that is equivalent to 1. Now negative 3 multiplied by negative 3, that is positive 9, plus negative 2, that is positive 7. So again, we have negative 3 multiplied by negative 2, that is positive 6 plus 5, that is equivalent to 11. So copying this one, the third row, since we don't have any process for the third row, so we'll just copy that one. So as you can see, we've already changed our 3 to 0. Now the next process or the next step that we need to do is we have to also 0 this one, number 2. So the same process, we just have to find any other processes now to get to change our 2 to 0. So we can have that as equivalent to R3 plus the negate of our 2, which is negative 2, multiplied by R1. That is equivalent to our new R3. So copying our rows 1 and 2, we have 1, 0, negative 3, and we have the negative 2. And then we have 0, 1, 7, and 11. For this one, negative 2 multiplied by 1, that is negative 2, plus our 2, so that is equivalent to 0. Now, negative 2 multiplied by 0, that is 0 plus 2, that is 2. So just copy that one. And then we have negative 2 multiplied by negative 3, that is 6 plus 1, that is 7. And then negative 2 multiplied by negative 2, that is 4, plus 4, that is 8. So as you can see, we've already changed our 3 and 2 to equivalent to 0 and 0. Now the next process now is to have this one zeroed as well. And we need to also have this one equivalent to 1 since that is part of our diagonal elements. So the next step now is to alter or create a process now to have this 0 first. So what process can we do or can we apply to make this a 0? So perhaps we can apply this one as equivalent to row 3 since we are altering row 3 plus this is 2, so we just have to find the negation of this one, which is negative 2. Then we need to find multiplied by 1. So 1 is in the row 2, so we can multiply that by row 2. So we can already have our new row 3. So copying the same result, we have 1, 0, negative 3. And then we have the negative 2. We have 0, 1, 7, and 11. And then for this one, negative 2 multiplied by R2, that is 0. 0 plus 0, that is still 0. So copy that one. Now afterwards, negative 2 multiplied by 1, negative 2 plus 2, so we have 0. Negative 2 multiplied by 7, that is negative 14, plus 7, that is negative 7. And for this one, we have negative 2 times our R2, so we have negative 22 plus our 8, which is equivalent to negative 14. But as you can see now, we've already zeroed out these elements. However, this still remains to be negative 7. Now, what we need to do is we need to find another process again so that we can eliminate negative 7 and we can replace that one as equivalent to 1. So what process can we do so that negative 7 will be changed by negative 1? So basically, we can multiply that with the reciprocal of itself, right? So we have R3 multiplied by reciprocal of itself, meaning to say we have negative 1 over 7. That is now our new row 3. So that gives us equivalent to copying our first and second row. We have negative 3 and we have negative 2. We have 0, 1, 7, and we have the 11. So R3 times negative 1 over 7, R3 is 0, so that is still 0. 0 times negative 1 over 7, that is still 0. Negative 7 multiplied by negative 1 over 7, that is equivalent to 1. And negative 14 multiplied by negative 1 over 7, that is equivalent to positive 2. So as you can see, we've already have our objectives, which is to have our diagonal elements as 1 and the elements below it must be equivalent to 0. So basically this is already now the answers that we are looking for. But how can we know what is the value of our x sub 1, what is the value of our x sub 2, and what is the value of our x sub 3? So as we already got the coefficients of our equations, we can already rewrite this one again back to an equation form. So we have x sub 1. For the first row, we have x sub 1, and we have no x sub 2. So just leave that as is. And then we have negative 3 x sub 3 is equivalent to negative 2. For the second equation, we have no x sub 1, so we'll just go with x sub 2. So we have x sub 2 plus 7 x sub 3 is equivalent to 11. And then for the last one, we have x sub 3 is equivalent to 2. So it's very obvious now that the value of our x sub 3 is equivalent to 2. Now what we need to do is to find the value of our x sub 2 and our x sub 1. So as we know that from this equation, x sub 3 already has a value, so meaning to say x sub 2 is equivalent to 11 minus 7 times our x sub 3, which is equivalent to 2. So meaning to say our x sub 2 is equivalent to negative 3. And for this one, in this case again, we also have the x sub 1 as equivalent to negative 2 plus our 3 multiplied by our x sub 3, which is 2. So that gives us equivalent to positive 4. So meaning to say our x sub 2 is equivalent to negative 3 and our x sub 1 is equivalent to 4. Now, how can we check if the roots that we have for our equations are already correct? So basically, we just have to simplify or substitute that one to our original equations. And this part should be equivalent to this part. So x sub 1 is said to be 4. Then minus 3 multiplied by x sub 3, which is 2. So 4 minus 6, that is equivalent to negative 2. So meaning to say this is correct. Now for the another equation, this one, we have 3 times x sub 1, which is equivalent to 4, plus our x sub 2, which is equivalent to negative 3. So we can just write this one as negative 3 minus 3. And then we have minus 2, and we have the 2. So 12 minus 3, that is equivalent to 9, minus 4, that is equivalent to 5. So meaning to say this is correct. So for this one, the last one is 2, and then the x sub 1 is equivalent to 4, plus our 2 and our x sub 2, which is negative 3, plus our x sub 3, which is 2. So 8 plus negative 6. So we have 2 plus 2, that is 4. So meaning to say the roots that we have here is already the correct roots. So meaning to say x sub 1 is equivalent to 4, x sub 2 is equivalent to negative 3, and x sub 3 is equivalent to 2. So basically that is just how we perform or how we find the solution or roots of our linear systems using Gauss elimination method.